Okay, hey everybody. How's everybody doing? I hope you're all, again, staying healthy, staying safe, and doing as best you can under the conditions that we're still under. So we're going to do something different today rather than regular lecture. I'm going to go ahead and share my screen with you, but I'm going to go ahead and go over um, assignment 3 because I think it has some value to go over this information, and I think it can be useful for you, not only from a policy perspective to understand um, problem analysis from a policy perspective, but also maybe just practical information related to the assignment that can help you, maybe even in conversations with friends and family about what's going on. Um, and so I want to go over assignment 3, and I'll post the answer key on Blackboard with an announcement. But what I first want to do is just go over. So assignment 3, what I did was it's kind of a problem definition. There's a typo there. But basically a problem definition, it's the beginning of policy analysis where we define a problem, right? And so this is a very basic level problem analysis related to COVID, but it's still very much how a basic problem analysis would go for a policy analysis. Beginning with thinking about the characteristics of the problem, right? So I gave you some sources, and some of you asked if you could use additional sources, and that's fine as long as you always want to check the credibility. And for this assignment, I use news articles. Typically try to use kind of scientific based information. The New York Times articles, I tried to use articles that cited actual scientific information. Of course, news outlets always have some perhaps form of bias. It's always important to acknowledge that and be aware. In a formal problem analysis, you would primarily be citing scientific studies explicitly, right? But this is just a simple practical approach for the class and related to what's going on. So just to jump in, and again, when I'm grading this, essentially, I'm just going to be looking at, did you cover the basics? There's no real necessarily like right, or there's definitely a wrong answer. But I'm just looking for engagement with the material, right? So I have some responses here. But just because you maybe don't have this specific response and you didn't write it in this particular way, it doesn't mean you're wrong. Okay. I also didn't ask you to have citations, but I added citations just out of habit. I cited the articles just so you can kind of see where I pulled the information from if it's not explicit where I pulled it from. So again, just basically, and I have a little thing in my throat. I'm not sick. I promise. But what kind of disease is COVID-19, right? And so again, this is just practical information, and it's really important for problem analysis, defining a problem, right? What are we dealing with? So the coronavirus is this respiratory illness, typically starts in the lungs, and it's really part of this family of viruses, right? The coronavirus family, 7 of which, so there's many more different types of coronavirus. That's why COVID has been named. We call it coronavirus in general, but the actual name, right? Many people refer to it as novel coronavirus or COVID-19 as a specific type of coronavirus within the coronavirus family, right? So there's 7 types which are known to be infectious to humans. 4 types that are known to be infectious with minor illnesses. So of those 7, 4 of the coronaviruses that we know about are kind of minor illnesses like the average cold, right? But 3 have been linked to a serious health impacts, such as SARS, which was the last kind of, I believe, one of the last kind of coronavirus, like kind of epidemic. It wasn't quite, I believe, a pandemic, whereas currently we have this pandemic. It's global, right? But SARS was, it spread in a number of places. So COVID-19 is this coronavirus, part of this coronavirus family, and it's one of the few. This is the 3rd one. So previously we had 6 known types that are infectious to humans. We knew that there were 2 that had serious health impacts, but now we know that there's 3 with COVID-19. And that coronaviruses are kind of known to be zoonotic. I don't know if I pronounced that correctly. But this basically means that they can and they're often originate from animals and they're transferred to humans. So animals kind of carry this thing and it gets transferred over to humans, right? So that's kind of the basics. What is this thing? What are the effects? Well, and again, there's more detail than what's covered in the news articles, but and even these news articles, because this information moves so quickly, most of this information is still accurate. But you know, the statistics change. But I threw some statistics in here just so you have an idea of maybe how you would cite these types of things in practice. And maybe some of you did this. I really haven't gone over the assignments yet, but I'll get to that quickly. But there's really no, and that's what's kind of interesting. There's not a single diagnostic symptom for, in particular, COVID-19, right? And many of you probably already know this. But what we mean by that is like there's not a single thing that we can say, oh, you're experiencing this, you might have COVID-19, right? There's a number of different symptoms that people test positive for COVID-19 have. Not everybody necessarily has all of the same symptoms, right? So among the most common symptoms of individuals who are infected with COVID-19 is a dry cough. And so these symptoms are found in a high percentage of total cases. Dry cough, right? So about 2/3 of people who test positive for COVID-19 have a dry cough. A little over a third, 38%, have fatigue. Oh, excuse me, let me back up. Fever is really a common symptom of coronavirus. Let me back up and highlight that. 87.9% of cases, individuals who test positive have symptoms of fever. Okay, so most of you probably know that that's a primary symptom. That's a very common, among the most common, but not everybody that tests positive for COVID-19 has a fever, right? So this statistic here, which again may have changed in the last couple of weeks, but 87.9% of people who test positive have a fever. About 2/3 have a dry cough, so not everybody, but 2/3. A little over a third, 38%, exhibit fatigue, right, tiredness, and those individuals test positive for coronavirus. Phlegm, the stuff that gathers in your throat and you cough up, about a third exactly, and again, this statistic may have changed, have phlegm production. A little less than 1 in 5, less than 20% have shortness of breath, and even fewer have what is referred to as muscle and joint pain, right? So aches and pains. And again, maybe an individual that contracts coronavirus has all of these symptoms, but in many cases we find like you might have 1 or 2 or a few of these symptoms, but not all of them, right? And so this is an interesting finding related to COVID-19. Does it affect some groups more than others? And there's a second part to this question at the end of the assignment, which we'll talk about, but just preliminarily, right? This is a lot of the stuff we were initially introduced with, is that it's important to note that of course anybody is susceptible to getting COVID-19, and anybody potentially is susceptible to having severe health-related impacts associated with COVID-19. What data has shown, right? So anybody can get it, and anybody can get seriously ill and have serious health complications as a result, right? But statistically, what we're finding is that children in general are less likely to require intensive care. It doesn't mean that if a child gets it, they won't require intensive care, but statistically speaking, they have lower levels, lower likelihood, and generally have lower fatality rates than adults, right? So again, anybody can get it. It's just we found that children that get it, percentage-wise, tend to have less likelihood of having to visit intensive care or experiencing a fatal illness as a result from COVID-19. Many of the known cases have been identified in adults, of course, and initially and even now, particularly in adults over the age of 40, right? And it's important to note that a lot of the challenges we have is testing. We still have this issue of testing going on, but that presumably many more people know it than have COVID-19 or have had it than we currently know, right? And so, you know, the higher number of individuals over the age of 40 that have the cases, right? This could just be a function of when you're over 40, perhaps, and we'll get into this, but older members of the population have a higher likelihood, right, of having serious health-related issues related to COVID-19. And so even especially in the early days of this pandemic, that you really didn't get tested unless you were showing strong symptoms, particularly with respect to fever, right? And so if you're older, right, and you have symptoms, and perhaps you're more likely to have serious health-related effects from COVID-19, you're more likely to get tested, right? So it's important to note that like testing is a really important information tool for this policy problem, right? And we're still limited in terms of testing capacity. But it's important to note that, people over the age of 40 were probably, and probably still are, more likely to get tested in places where there's a shortage of testing, because testing is typically limited to those more vulnerable members of society. So getting back, does it affect some groups more than others? Well, COVID-19 is more serious health threat for people with underlying conditions, right? So this is also statistically supported. And again, the statistics here in the assignment may have changed, and this is a dynamic problem it's continuously changing as information gets updated, data becomes available. But generally speaking, individuals who have cardiovascular disease, right? This is, we're talking about lung diseases, because respiratory illnesses, because this is a disease that kind of attacks, if you will, the lungs, that if you have already lung problems, it makes it a little bit more likely that you'll have severe health-related effects from COVID-19, right? If you're diabetic, right? If you have chronic lung disease, high blood pressure, cancer, right? You're more susceptible to, in this case, fatal health-related effects from COVID-19. And so, and I guess, the articles I gave you didn't really get into the why, but a lot of this has to do with, things like compromised immune systems, where your body's already fighting different things on a regular basis. And again, as we get more data and more information, this link becomes clearer. But statistically speaking, this is what we tend to find, right? That people with underlying conditions tend to be more susceptible to having fatal responses to COVID-19. Whereas individuals with no underlying conditions, right, have a mortality rate of about 0.9%, right? So less than 1 out of 100 people that have no underlying conditions die as a result of contracting COVID-19, right? So, and again, this could be practical information. So this is a part of problem analysis, understanding what is the issue, what are the symptoms of the problem, right? And who is primarily affected, who might be affected more than others, right? This is all important information to know from a policy perspective. And again, for you all, it might be practical information to know in terms of your personal, health conditions, but also family, friends, right? It's important to get good information to people and just understand, like I said, that these are statistics, they're based on data, but the data is changing. It is a dynamic area, but arguably this data is still relevant and applicable. It's just that the percentages may change here and there, right? Where did it come from, right? So again, from a policy perspective, we want to identify the causes of the problem. And this is also important to note that we're still investigating this and still learning more. But what we do know, and again, it's important to note that information is continuing to be gathered. That's why I put, where do we think? That most of the COVID-19 cases, the original cases, have been traced to an animal market in Wuhan, right? A city in China. And this is like a live animal market. I think they call them wet markets, right? Therefore, so people get this COVID-19, the early cases, and a number of those early cases, they traced their behavior, right? Like, where were you in the last couple of weeks? What places did you visit? And this particular market was a commonly shared destination for people that were initially identified as having COVID-19. So again, this is just based on like investigatory work, right? It doesn't mean that it's the place of origination, but it's what many believe to be the place of origination, although this investigation is still ongoing. And so it's believed that COVID-19 was transferred to humans from animals, perhaps at this particular market. Why did COVID-19 spread so quickly? And the articles don't get exactly into this specific answer. But again, I want you to be thinking, and this is just to think about what are the causes, right? The causes is this, the problem is this global pandemic, right? This global pandemic that can have fatal implications for people. It can be particularly fatal and serious for people with certain conditions. But it is important for everybody to be aware of the potential effects of contracting it, because we don't really know, right? And just as an aside, what I always tell my friends is that, and I don't have this statistic in here, but they're saying that about 80% of the population, right? So 8 out of 10 people are maybe asymptomatic or only experience COVID-19 in a mild way, right? So this means that 8 out of 10 people get COVID-19 and they don't experience serious health conditions like they have to go to the emergency room, right? But 20% of the population perhaps does, right, get serious health impacts. And so, what I tell my friends, because we're in New York City, right, and I have friends on the West Coast where this thing is everywhere, but it's particularly bad here in the city, is that, I don't know where I'm at in that 8 out of 10. Maybe I'm the 8 out of 10 that gets mildly ill from coronavirus. I don't have underlying conditions, but there's always the chance, right, that if you do get it, that it might be serious for you, right? And so this is a reason perhaps to be precautionary with how we interact under the existing climate of the pandemic, right? So anyway, why did it spread so quickly, right? So this is part of understanding the causes of the problem, this global pandemic. What caused it, right? Well, it's highly infectious. This is a highly infectious disease. It spreads very quickly and easily, I guess. That's maybe not the best term, but it spreads. Perhaps more highly infectious than the average, flu and things like this. And so it spreads very quickly, or it's highly infectious, which allows it to spread quickly. It spreads through small droplets, saliva, mucus, which of course is released when we cough or sneeze, but even when we talk, right? And this research is continuing to grow to understand how long do these tiny droplets stay in the air? Because we're talking like aerosol-sized droplets, like really tiny droplets, not like water droplets like the rain, but stuff that can like float in the air. And so there's important questions like, this is what we know. The bigger question is, how long does it stay in the air? And that information is also dynamic as people do research, do studies to try to understand this. But essentially, these small microscopic droplets spread, right? And maybe 3 to 6 feet, which is why we have this kind of 6-foot social distancing in place. And then it's believed that these droplets can live on surfaces for up to a couple days, right? And this changes also, and the articles didn't get into details, but the surfaces that it lives on, the length of life that the droplet, that COVID-19 has in a droplet, varies depending on the type of surface that it's been deposited on. Certain surfaces it lives longer than others and things like this, right? And I don't know that it's living, but it remains, infectious. You can get it from it being on the surface, which is, and we'll get into this, what I want you to do in the next couple of weeks or a week or so. But, what are some of the policies we've seen implemented or practices, right? One is washing our hands. Well, why, right? Because we could be touching something that has it, and then we touch our face and we get it, right? And so, so this is just a basic understanding of what are the causes. It came from this place. We need to know where it came from. But we also want to know, like, why is it spreading? What's causing it to spread, right? What do we need to do? If this was spread some other way, if it was spread through, transfer of blood or, specific interaction with like kissing or some type of, a sexually transmitted disease, right? This is not that. And because it can be transferred through saliva, through droplets, right? This is why we have things like social distancing, right? Whereas if it was some type of blood related, I don't know, that you have to be exposed or direct in contact with someone's blood, um, you know, maybe social distancing wouldn't be as necessary, but this is why we have social distancing and things like this, because we understand this about the problem. So just to get through to the context, right? So what is the extent or the magnitude? And I kind of explain, and this varies perhaps depending on the problem that we're talking about. But when we talk about like the extent, you know, generally how I like to think of it is, you know, how widespread is it? How widespread is it in the world, in the nation, in the state? And what's the magnitude? How big is the problem, right? Is it widespread, but only a problem for certain groups? What is the magnitude? And so I linked you to these different sources, and I'm gonna open up, I'm gonna make these viewable. But I linked you to these different sources to kind of get a good, and again, this could be a good source to kind of keep track of what's going on. But the New York Times puts this together and they update. So the first question before we get into the data analysis is what indicators are used to kind of track the extent, the context, the extent and the magnitude of the problem? And there's arguably more indicators, but in what I presented here, what's being tracked are the total cases, or excuse me, what's being tracked are the cases, right? So the identified positive cases of COVID-19, so people that test positive for COVID-19, and the number of deaths attributed or deaths related to COVID-19, right? So these are the two primary indicators that the New York Times here is tracking. There's other indicators as well, which we'll get into, but things like hospitalizations, right? But here, what's being tracked are cases, positive cases, and deaths. So I go on to ask each indicator, right? So cases and deaths are being measured in two different ways. List each of the two different indicators and briefly explain how they are being measured, right? So this is kind of a weird question. And again, like I'm going to be, you know, I've been fairly flexible with answers. I just want to see effort and some engagement with the material. But what we have, as already mentioned, is the number of cases and deaths related to COVID-19, how that's being tracked in two different ways. So these are, you know, indicators, quantitative measures of the coronavirus problem. So what we have is the total number of cases and the total number of deaths within a particular region, right? So what's being tracked are the totals, total cases, total deaths in a country, in the world, in a state, in a county, right? We're getting that total number. What's also being tracked is the per capita amount of cases and per capita amount of deaths within a region. Now, this might be a new term to some of you, but per capita generally means like per person or per certain amount of people, right? So in this case, how per capita is defined is per capita calculations includes the number of cases or deaths per 100,000 people, all right? So what you do is you would take, if you're looking, and we'll look at this, but if you're looking at the US, you take the total number of cases in the US and divide it by the total population of the US, right? And this gives you the number of cases per person. Now, you can modify that to make it per 100,000 people. So you could multiply that by 100,000, and that would give you the amount of cases per 100,000 people, right? So that's what we're working with here. Per capita data is the second way that those indicators are being measured. Why are they doing this? And I want you to pay attention to this because I am going to kind of ask you about this perhaps on an exam, and maybe even on a quiz. But why do we use per capita? Well, when you look at the total number, right, you know, it can be kind of misleading, right? Where a country that has a lot of people can have a lot of cases, right? And so the total number of cases in the US are high, right? And we'll look at this, they are high. But if we don't take into account like the total number of cases in the US versus the total number of cases in a much smaller country, like let's just say for the sake of argument, like Ireland, right? Is a small island country. The US is going to have a lot more cases, a lot more total cases than Ireland, but we also have a lot more people, right? So in order to make comparisons between countries or between states or between counties or cities, we often use per capita, which basically just gives us, again, it controls basically for differences in total population. So if we just look at the number of cases per 100,000 people, now we can make comparisons. Whereas if you're just looking at total cases, that's good information, but you're not taking into account differences in population size, all right? So per capita measures take into account those differences, the differences in population size. And it really is useful, and I put it here because it's particularly useful for making comparisons. And this can help us to think about the magnitude of a problem within a region, right? What is the magnitude? How many people have it here? How many cases per 100,000 people here versus per 100,000 people somewhere else, right? And this allows us to make those comparisons, that per capita measure, right? So I ask you first to identify, and again, I have some answers here. I just highlighted on the screen. I have my response written out. If your response isn't exactly written like this, there's a lot of different ways you could have looked and analyzed this data. And that's fine, as long as you're somewhat looks like you're applying the data to try to explain your answer. That's all I'm looking for. But this is kind of a good way to think about this and maybe useful for you to have access to. But I also want to highlight in the beginning that answers may vary depending on when you view the data, right? So if you look here, if you go back to the link, you can see that this data here was updated on April 30th of 2020, right? And so as of April 30th, this data was updated, so it's already different than it was when you viewed it, right? And so let me just, yeah. So anyway, so what does the US look like, right? So we go here, I mean, there's a lot of interesting data here. One thing you can see maps that showed like basically like hot spots, if you will. You can look at total cases, you can look at deaths, you can look at per capita numbers, new cases, right? But what I would have looked at here, and again, I just have to see what people wrote, but if you go to like the country table, this is a pretty useful source of data for thinking about the extent and the magnitude of the problem in the US and actually having some numbers, right? So here, so let's start here in the left column. So what we have here is the number of cases, total cases, right? And so I highlight this here. As of April 30th, let me go to the top. So as of April 30th, 2020, there were 3.1 million cases and approximately 229,000, almost 230,000 deaths due to COVID-19 globally. All right, so this is at the global scale. Now, if we go to this country table, we can look at the US relative to the rest of the world. All right, so I'm just going to highlight what I'm talking about here, but the US has the greatest number of cases with 1,057,812 cases, right? And again, you don't have to calculate this, but I went ahead and calculated it. What I did was, and so the US accounts for about 34%, a little over a third, 1 out of 3 cases worldwide are in the US in terms of what we know from testing, right? So again, testing is a limiting factor, but what we know from the testing is that more than 1 out of 3 cases, just over 1 out of 3 cases are in the US, okay? And how I calculated that percent was I just took that 1 million, 1,057,812, I divided that by basically 3.1 million. And then I multiplied by 100, and that gives you that 34%. Again, I didn't expect you to do that. This is not a quantitative class necessarily, but if you did that, but it just gives you some perspective. Again, these are quantitative measures that give us some perspective. So in the U.S., we've got, the extent in the U.S. And the magnitude perhaps relative to other places is quite high. 34% of all cases are in the U.S. Now, let's look at, so why is that? Well, the U.S. has over 500 million people. And so perhaps the U.S. is a large country relative to other countries. And so we ought to think about differences in population size. So if we go over here to the second column, cases per 100,000 people, if you click on that, and again, I expect you to do this, but you can see just by looking here. So we look at cases per 100,000 people. The US has 323 cases per 100,000 people. But just looking at Spain, so they have 457 cases per 100,000 people, right? However, Spain only has 213,000 cases relative to our 1 million cases, right? So they have 1/5 of the amount of cases that we do, right? You could multiply Spain's total number of cases by 5, and then they, on a total basis, they would be where we're at. But they have a higher per capita amount of cases. So what this tells us is that controlling for population size, because Spain is a much smaller country, when we control for population size, it tells us that, and if you click on this link here, you'll see that the US disappears, and I'll open this up. But when you click on that, what it does is it sorts the countries based on the per capita ratings, right? So all of a sudden, rather than the cases being ranked by the amount of total cases, you have it being ranked, you have countries being ranked by per capita cases. And so San Marino here pops to the top, 1,684 cases per 100,000 people, right? Pretty high. And the next one down, Andorra, 967, Iceland, so on and so forth, right? Qatar. And if we scroll down, you can see the US is down here. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So I have this here. So the US has the greatest number of cases. However, when we control for population, the US is ranked about 15th, right? With 323 cases per 100,000 people. So, and you can roll down through this table here and see that, so the US is not top in terms of per capita cases. There's 14 other countries that have a higher rates in terms of per capita amount of people with COVID-19 than the US. The UK is just below the US. So the US is not at the top. It's about 15th, but certainly the US is among the top, right? Because we can scroll down, right? There's a lot of countries below the US, right, in terms of their per capita cases of COVID-19. So, so while the US is not, and I'm just showing you that, you can look at this on your own. But so while the US is not the top, I mean, there's certainly a high magnitude in the US relative to other countries that are not within this like top 20, right? So what I said here, so there's that, okay? So next I want to move over to deaths. And so if you click on this, it'll resort. But you can see when you resort based on total deaths, the US pops back up to the top, right? So the US leads the world in terms of total number of deaths. And I broke this down here. Total number of deaths, 61,000 plus. Approximately 27%. So more than 1 out of 4 deaths attributed to COVID-19 have been in the US, right? So a quarter of deaths linked to COVID-19 have occurred in the US. So again, the US is at the top there in terms of total deaths, right? But for the sake of making comparisons, we should think about, so the total deaths, as with the total cases, is important information, right? We have a high amount of cases here in this country relative to other places. And now let's make comparisons, right? So now we can sort the table in terms of per capita deaths. And we can see, again, when we do that, that the US pops down San Marino, which also had the highest number of cases per 100,000 people, pops up to the top again with 121 deaths per 100,000 people. And we can scroll down here, and we can find the United States down here with about 19 deaths per 100,000 people from COVID-19, right? And so again, what I wrote here is that, however, in terms of the death per 100,000 people, in terms of that per capita measurement, the US is ranked 15th, 19 deaths per 100,000 people. And so again, this allows us to make comparisons. So what I did was I kind of summarized that. And again, I'll look through the answers. I'm not going to be a stickler for this, but just for your information, right? One way to summarize this, right, is we could say the COVID-19 problem in the US clearly has high magnitude, right? It's got a high number of cases, right? So it's very high. At the international level, the extent, right, the spread, the ubiquity, in the international context, the U.S. is among the top, but it's not at the top, right? So it's relatively not low. I don't know. I guess I didn't put a word here, but I guess you could say medium or moderate levels, right? So the U.S. is in the top 20, but it's not in the top 5. There are other countries. So the magnitude of the problem in the U.S. is high. We've got a lot of number of cases. We've got a lot of deaths related to COVID-19. But when we think about the extent, how widespread is it, right? If we break it down to the 100,000, if we control for population, we can see that the extent of the problem in the U.S. is high. Right? It's higher than a lot of other countries, but it's lower than 14 other countries, right? So in other countries like San Marino, Belgium, Spain, it's Italy, the extent is perhaps much greater or relatively greater. And when I say relatively, I just mean relative to other places, right? So that's kind of what I'm looking for there, is just some engagement with the data, kind of making some comparisons. And again, this helps us to understand the context of the problem. What is it like here in the US versus other places? Why should we be concerned in the US? Well, we've got high magnitude, and the extent is not the highest, but it's pretty moderately high extent of issues with COVID-19 in terms of cases and deaths. Now let's look at New York, right? Let's situate New York in this conversation. So I'm going to go to that next set of data. So the other source I gave you showed states, right? I think, right? Oh wait, here we go. The other source I gave you was state level data. And again, this is updated on April 30th, 2020, right? Very recently. So answers may vary depending on when you view the data and how you analyze the data. But as of April 30th, okay, the US had about 1 million cases and approximately and over 61,000 deaths attributed to COVID-19, and that information is here at the top. And you can see this interesting figure where it's leveled off, right? And we will talk about this in the coming weeks, the last few weeks of class. But we see this kind of exponential growth and then a leveling off. But we're at 1 million cases, 61,000 deaths. And you can look at this visually on a map, right? You can see New York just pops out as like this hotspot in terms of total cases. You can look at this map in terms of deaths. New York City, in this case, kind of pops out, which is why many people refer to New York City as the epicenter of this pandemic. Per capita, again, you get some coloration there. You can get a feel for the extent of this problem in different places. But anyway, again, I'm going to go back to the tables, the cases by state. So we've got 50 states, right? So how does New York compare to other places, right? So the cases start off being ranked on total number. So New York has the greatest number of cases, 309,000, about 31% of the US's total number of cases. Now, so just under a third, just under 1 out of 3 cases in the US are in the state of New York, right, the state. Now, if we sort those cases based on per capita, per 100,000 people, New York stays at the top. All right, so New York's got a high magnitude of cases, we've got a high number of total cases relative to other states in the country. We've also got the extent of the problem is also quite high here, right? Relative to other states, we've got the highest per capita cases of coronavirus with 1,500 or so per 100,000 people. And so again, the magnitude is high, arguably the extent is high. If we switch over to thinking about the number of deaths, New York State, again at the top, 23,000 deaths attributed to COVID-19. The next lowest state, which I added to this response just again for comparison, the next lowest state is 6,000, right? And that's just over in New Jersey, just across the river here. But we're substantially high in terms of totals relative to other places, right? So you could say, well, New York has a lot more people than New Jersey, right? So we ought to control for population rather than looking at these total numbers. So then we can do this per 100,000 people. What we see here is that New York, again, stays at the top, the most deaths per 100,000 people from COVID-19. When we control for population, it's still greater than New Jersey in terms of the number of deaths per capita, which New Jersey has 76, right? So New York is at the top. That's, when we think about why is New York considered this epicenter, well, the US in general is among the top in terms of where it sits in terms of the impact of COVID on the population. The US is in those top numbers of countries, top 15, right? Certainly within the top 20. If we look at the US, New York is right there at the top, right? So this is why we talk about New York as kind of this epicenter of the pandemic. And so, kind of how I summarize this here is that, we think about the COVID-19 problem in New York, it's got high magnitude in terms of total cases, right? We see a high number of total cases and deaths in the state of New York relative to what we see throughout the country. The extent is also really high. When we control for population, we see that relative to other states, per 100,000 people, we have greater numbers of cases and deaths from COVID-19. And so this establishes kind of New York as this kind of epicenter, right? And so the last thing I wanted you to do was go to this third source that gets to New York City itself, right? Within the state of New York. So if we look at New York State, that's what this map is here, or this page is here, again, updated on the 30th of 2020. In the state of New York, 309,000 total deaths, cases, 23,000 deaths. And we can look at the long-term trend here. Thankfully, it's been steadily declining, but we still have positive numbers, right? And I just want to note that this could be kind of difficult. I know that this assignment could be difficult in terms of maybe emotionally or stress-wise, but I think it's of value to be exposed to this information and really reflect on it because it is very startling data to look at. The fact that you all live in New York City currently is understandably intense, right? And the fact that you're living in the center of this kind of global pandemic is incredible. I mean, I don't mean incredible in a good way. I mean incredible in the sense that it's what's going on here in New York City is not being experienced by other places in the US to the degree that we're having it, right? And so I know I've said this in other lectures before and in emails or whatever, but that I have the utmost respect for you all, and that 90% of you are continuing to try to do this school thing, and I commend you on that. It's not expected, right? Because you have family stuff, work stuff, financial stuff, all of these things are happening all at once. And you all, in New York City, in the Bronx, are being hit arguably the hardest out of any place in the country. Certainly in the country, perhaps many places throughout the world, it's happening hardest here. And so this data can be difficult to wrap our brains around, and maybe it evokes some emotions, and that's okay, you know. What I've been telling people that I've talked to in email is that it's okay to not be okay, right? It's okay to have some feelings around this whole thing, and not feel good about what's going on, and feel uncomfortable with the uncertainty. But just know that, you know, this is unprecedented, and you all are living in the center of it. And this is, again, just a really unique situation. And so that's what I wanted you to understand with this, and from a numbers perspective, right? So if we look at New York City, within the state of New York, so we could look at a map, and again, you can see the city here as kind of a hotspot within the state of New York, in terms of deaths. Again, New York City, a hot spot there. Per capita, New York City and the surrounding areas, all right? And new cases mostly outside of New York. And we're not going to get into this, but it says, you know, what is the shelter in place doing, perhaps, right? That the stay-at-home order maybe is doing what it was intended to do. Hopefully it is, because it's uncomfortable for everybody, right? But this is maybe the best thing that we can do at this time, in light of the consequences, right? So if we look at New York City within the state, so if we look at New York City, has the greatest total number of cases within the state. So the city, 172,000 cases. Out of that, kind of 300,000 total cases. This is about 1 out of 2 cases in the state of New York are happening in New York City, right? And again, this data changes, but not dramatically from day to day. So about half the cases in the entire state are in New York City. Now, if we look at cases per 100,000 people, New York City shifts down to about 1, 2, 3, 4, 5, to about 6th place, right? That per capita cases in the state, Rockland County, which is not far from the city, right, has the highest number per capita, followed by Westchester, which of course is just north of us here in the Bronx, Nassau County, which is over there, Long Island area, right, and then Orange County and Suffolk County, again, Nassau's in Long Island, right? Yeah, Suffolk also down there. But that, you know, New York City is about 6th, right? But all these places in the top 5 are basically suburbs of New York City, right? And so that's important to note, but New York City does not have the highest per capita, although it's not far behind some of these places. But Rockland County has a relatively high per capita, right? 3,600 versus 2,900. It's relatively high compared to the other places. And so again, I noted that here in terms of per capita cases, ranked 6th. My cat's scratching on my wall. He's kind of losing it with me being here all the time with him. He wants me to leave. So yeah, so that's the cases. Let's look at deaths. So in terms of total deaths in the state of New York City is you know, at the highest there, right? And so I summarize this here. Highest number of total deaths, which if you do the statistic, you know, do the math to get the statistics, approximately 75% of the state total for New York State, right? The total deaths in New York State, 3 out of 4 of those are occurring in New York City, right? So very, very high in New York City relative to other counties in the state. You know, and you can look down, like if you just go to the next highest number, Nassau County, 2,000 or so, right? 17,000 in New York City versus Nassau County, 2,000. But again, New York City has 8.5+ million people. So we ought to control for population in order to get some kind of comparisons, right? Some comparable data. So if we click on this link, it sorts the counties based on per capita deaths from COVID-19. And we can see that New York City is at the top with 211 deaths per 100,000 people. followed by Nassau County, 156. So Nassau is still there, but this gives us some comparisons, right? That per 100,000 people, New York has about 65, 55 plus more deaths per 100,000 people, right? And so again, that per capita allows us to make comparisons, right? So just a summary here, the COVID-19 problem in the city has high magnitude and high number of cases, has high magnitude due to its top ranking in terms of total cases and total deaths. But if we look at those per capita numbers, it tells us that the extent of the problem in the city is also high, right? And so again, all of the data we just kind of looked at is, well, why is New York City the epicenter of this pandemic? Well, if we look globally, the U.S. is among the top. Certainly, if we look in the nation, New York State is among the top, and then in terms of counties, New York is New York City in the state. New York is right there, right? So we're at this epicenter of this pandemic, and that's kind of the data to show you that. Now, I want to also get into thinking about some populations being impacted more than others in terms of this pandemic. So, you guys, I don't know if you want Marvin in there. Hey, boy, yeah, he's a big cat. But I also had a question about are some populations disproportionately affected by this relative to others? And there have been news articles about this. This is about equity, right? So we've talked about equity as a measurement of policy analysis, or equity as an evaluative criteria of policy analysis. When we think about diseases, anytime environmental conditions, illnesses, a lot of times scholars, academics, researchers think about this equity issue, right? Are some populations being disproportionately impacted than others? This helps us know, perhaps where to focus efforts. Where are there gaps in where efforts are being applied? Understanding this information can also shed light on inequities in how populations are being treated, concerning something like a global pandemic, right? Are some being left out of efforts to address the issue, right? And so that's why I kind of threw this in here. Certainly Lehman College, certainly many of you, right, could identify with this as students of color, certainly as residents of or New York, residents of New York City and or residents of the Bronx, can identify with this. And so it's important that we note that if you look at the data, and the articles highlight this, although this data is preliminary, right? The data so far indicate that people of color, and the articles I asked you to read particularly speak about Black populations, but just in general, people of color have been identified to be disproportionately impacted by COVID-19 relative to white populations, all right? So why is this, right? So if you look, for example, just to explain this and provide some context to this issue of equity, if you look at Chicago, the Black population in Chicago accounts for about 50% of those who tested positive for COVID-19. Right, so 1 in 2 people that tested positive for COVID-19 are Black, and 72% of virus-related deaths. All right, so almost 3 out of 4 deaths are Black members of or Black residents of Chicago. All right, so whereas 1 in 2 who test positive are Black, that's a high percentage perhaps, because it's not just Black and white people living in Chicago. There's brown, there's Asian populations, right? And so, but 1 out of 2 are Black. But also the important statistic that 3 out of 4 people, right, who have it and die from it are Black as well. And so if we look in the entire state of Illinois, right, Chicago is in Illinois, the Black population accounts for about 43% of deaths in Illinois, in the entire state, and 28% of those who tested positive. But if we look at the entire population, right, so I'm going to zoom or scroll up here. the entire population of the state, black people only account for 15% of the state's entire population. Okay, so 15 out of 100 people in Illinois are black. Okay, 15 out of 100. But 28%, 1 out of 4, more than just over 1 out of 4 people who test positive are black, right? So 28 out of 100 who test positive are black, but the black population only accounts for 15% of the total population. So what this is telling us, and then if we look at deaths, 43% of deaths. What this is telling us is that in this data that's being presented, is that black residents of Illinois are disproportionately impacted by COVID-19. What I mean by that is that if it was proportionate, what you would expect to see, because 15% of the population in Illinois is black, that if it was proportionate, you would have like 15% of the deaths, right, would be black. 15% of those who tested positive would be black. But those who tested positive and those who died are much higher than that, right? And so what this tells us is that black residents are disproportionately impacted by COVID-19 in terms of likelihood of getting it, and also likelihood of having fatal consequences from getting it, right? And so this was also found to be true. And again, a lot of this data is still coming in. It's still preliminary. Places like New York, California, they're getting a little bit, they're getting pressured to collect this data. So not all places are necessarily collecting the demographic, the ethnicity, race data that helps us to identify these disproportionalities in exposure to COVID-19 and health-related impacts of COVID-19. But what the preliminary data, again, preliminary, but what it's showing us is that this is also being found in state of Michigan, Louisiana, Minnesota, North Carolina, South Carolina, and it was also identified in the article talked about in Las Vegas, right, city of Las Vegas. Why does this disparity exist, right? So again, this is not a scientific study, this article, but it does interview academics, researchers who can speak to maybe why these types of things are existing, right? So this is not a study. If you were to do this in an actual policy analysis, you would do a formal study perhaps of this exact issue. But what we found is that there's a number of reasons why this exists, and I just kind of provided a quick summary. One is in a lot of these places, right? In some of these communities, particularly like South Carolina, North Carolina, Louisiana, certainly Michigan and parts of Illinois, like Chicago, you still find segregated communities. And I don't mean it's not like legal segregation. It's just that you find communities where predominantly black, predominantly white, right? You have separation of communities, not separation, but segregation of communities based on race, right? And it's still fairly common to see that. And so what this means is that, so we have this segregation of communities where, black populations in a city or area tend to live amongst each other more so than it is mixed, right? And so we take this with, I'm going to go to the third point here, but blacks also, again, statistically speaking, disproportionately work in fields that really don't accommodate the opportunity to work from home, right? And so lower likelihood of working from home. So you have, this particular population is commuting to work, maybe using public transportation when you're in a major city. But nonetheless, you're commuting to work, you're going to work. You're out, you're not working from home. You're spending more time outside of the home. So therefore, you might be more likely to contract it, right? Again, just statistically speaking. But then you also go home, and when you're in this community that's predominantly black, right, it's higher likelihood that the person that might get it from you is also black, right? And so you have this kind of community spread type of situation within black communities due to, again, this can be compounded by that kind of segregation factor. Whereas if you had more mixed communities, that it might not be as disproportionately impactful to a particular population. Why are people getting so sick from coronavirus, right? Well, Black populations, and this is discussed in the first article here, are more likely to have kind of pre-existing health conditions. They talk about high levels of stress-mediated wear and tear, right? That exposure to stress, discrimination, all these things can wear down a body, such that, in particular, and this is common with populations of color in general, but they highlight the Black community tends to, again, this affects things like livelihood in terms of life expectancy, right? This is scientifically uh, proven information, right? That there's this condition. Again, this is kind of an informal term, but stress-mediated wear and tear. That because of experiences of Black communities, that you have perhaps a lower life expectancy in these communities, higher levels of wear and tear. And you also have issues such as a lower likelihood of having health insurance, higher likelihood of having pre-existing health conditions. And the article, which again, the wear and tear, lower likelihood of having good insurance or insurance at all, and the pre-existing health conditions all make, right, in particular in this article highlights it, in the Black communities, are particularly susceptible to having, serious complications from COVID-19, right? When you go, you might not go to get healthcare until it's very, very bad because you don't have health insurance. So you might wait until maybe it's too late, right? But also just the pre-existing conditions might create a bigger problem for you health-wise. And so again, this is important to note that it might have a disproportionate impact on certain populations. You also have in this article talked about racial bias, right, concerning proper treatment, which, this is sad, and it will be interesting to see kind of where this data goes and what comes out of it. But some in preliminary data, again, this is kind of preliminary data, is finding that instances where, a person of color, in particular a Black person, might go to a local clinic while exhibiting COVID-19 symptoms, and perhaps there's some type of racial bias in terms of treatment, meaning that if a person of color, a Black person, goes to a clinic exhibiting symptoms, they have a lower likelihood of being referred to uh, uh, a formal testing service, and maybe getting proper care after testing positive. There's a lower likelihood of someone who's Black experiencing that referral process than someone who might be white and has the exact same conditions, right? This is what they're calling in this article racial bias related to treatment of COVID-19. And so again, this is kind of institutional racism stuff that we see here, existing health disparities, forms of discrimination, and this might, again, job opportunities, careers, that might be leading to the disproportionate impact on certain communities relative to other places and other races. I realized that the second article that I posted related to this didn't speak about this explicitly, but the second article talked about air pollution and higher rates of coronavirus deaths, okay? So the second article, and I'm just gonna skim through it, but what it talks about is this stuff called particulate matter, all right? So this is stuff that is caused by, I'm sorry, I'm just kind of skimming through here, I'm trying to find it. We're talking about is this particulate matter, and 2.5 just tells us the size of that matter. But what we're talking about is particulate matter is this stuff. It's basically like dust particles, like really tiny stuff that's like dust, basically, right? And particulate matter is an air quality concern. But one of the primary causes of particulate matter is fossil fuel combustion. It comes out of cars. It's kicked up off of roads like actual dust. And so what this article talks about is a study that linked higher instances of coronavirus deaths in areas where there's lower quality of air, particularly with respect to particulate matter. So when you have more particulate matter in the air quality is lower. And if you're breathing in that air, what happens is you're more likely to have respiratory problems because you have just congested lungs, right? And then you get coronavirus, and it's much worse for you than someone who has better air quality, right? And so this article talks about that. That basically here it shows New Delhi as like a particulate matter versus San Francisco versus New York. Um, and so, but statistically speaking, and this article didn't speak about it, so many of you probably didn't say this, but I already know this from research. But that populations of color are more likely to live in areas with poor air quality, right? Are more likely to experience issues of environmental pollution, right? And one of those environmental pollutions is air quality problems. So you have populations of color that are more likely to live in regions with poor air quality, particularly with respect to particulate matter, and are therefore more likely to have like respiratory illnesses like asthma and things, right? And so research has shown that people who live in regions with relatively poor air quality are more likely to suffer severe health-related impacts from COVID-19. So when we put those things together, we see that, therefore, if communities of color are more likely to live in places with poor air quality, and poor air quality is bad for COVID-19, therefore, right, we can kind of make that connection that communities of color are more likely or disproportionately vulnerable to the severe health impacts associated with COVID-19, right? And so again, this gets back to issues of equity, issues of disproportionate impacts of a particular problem on certain groups within society. And I wanted to kind of highlight this because it is relevant in terms of equity issues related to COVID-19. So that's what I wanted to go over for today's lecture. Yeah, we'll return to regular lecture on Tuesday. I'll post an announcement about that. But hopefully you're all doing well. And again, just understand that what this assignment has revealed, probably, hopefully, is that yes, we indeed are at the epicenter of this global pandemic, and it's harder for people here than anywhere else. Likely, it's very difficult. It's hard for everybody everywhere, but there's probably disproportionately difficult for many people here, and particularly in the Bronx. And I understand that it's hard for all of you, and that you're juggling a lot. So I have the utmost respect, and it's okay to not be okay. It's okay to have stuff pop up, to feel stressed out, anxious, sad, all of those things. It's perfectly fine to feel that way. And I'm here to help any way that I can. All right. So we'll get this lecture up. It's up if you're seeing it, and I'll talk to you soon. All right. Take care. And Marvin says bye. He doesn't want to turn around, but he's shy. All right. We'll talk to you later.